Calculus, particle motion with trigonometry. In the first semester, we worked on particle motion with polynomial functions. In this part of the course, we're looking at particle motion with trigonometric functions. In order to do this, we have to understand basic trigonometry, specifically the unit circle of trigonometry. And when you have a unit circle, like this one I'm drawing here, the key points involved here are along the x-axis 1, 0. And then up here at the top of the circle, the point 0, 1. At the left of the circle, the point -1, 0. And now at the bottom of the circle, the point 0, -1. And so the x values are the cosine value and the y values are the sine values. What I'm going to do is shrink the text of this problem here to leave more room for writing our answers. Okay, a particle moves along a horizontal line so that any time t its position is given by x of t equals 2 pi t plus cosine of 2 pi t. And part A is find the velocity at time t. Well, I'm just going to write up here. V of t is equal to the first derivative of the x of t function, which is going to be x prime of t. And what that's going to be is when you have 2 pi t, what is the derivative of 2 pi t? Well, it's going to be 2 pi. And then what is going to be the derivative of cosine 2 pi t? Well, it's going to be negative sine 2 pi t times the derivative of the inside, which is 2 pi. So that's going to be 2 pi minus 2 pi sine 2 pi t. So that is going to be our answer. And that's going to be v prime, or x prime of t, which is v of t. Now it says find the acceleration at time t. Well, acceleration is going to be equal to the first derivative of the velocity. And so we're going to take this, what is the derivative of this thing right here? Well, what is the derivative of 2 pi? That's going to be 0 because that's a constant. And then what is the derivative of sine going to be? Well, it's going to be cosine. So we have negative 2 pi cosine of 2 pi t times the derivative of the inside, which is 2 pi. And so just putting all the constants together on the left, we're going to have negative 4 pi squared cosine 2 pi t. So now we have our acceleration and our velocity. What are all the values of t for a t between 0 and 3 for which the particle is at rest? Justify your answer. Well, particles at rest where v of t is equal to 0. And so we can take this function here. So 0 equals 2 pi minus 2 pi sine of 2 pi t. And what could be helpful for us is to factor out this 2 pi. So 0 is going to be equal to 2 pi times 1 minus sine 2 pi t. And so what that's going to do is that's going to happen where 0 is equal to 1 minus sine of 2 pi t. And so solving this equation, we're going to have, if we add sine 2 pi t to both sides of the equation, we're going to have sine 2 pi t is equal to 1. And where do we see where do we have that happen? We have to have sine of pi over 2, because right up here at the top of the unit circle is pi over 2. So what we can do is we set pi over 2, pi over 2 equal to 2 pi t. And pi over pi will cancel out, and then we divide by 2. So we have t is equal to 1/4. So that is a value of t for which the particle is at rest. Now, the thing that we have is that not only at pi over 2 does that happen, but what if we go around and have another coterminal angle and go, you see that this doesn't, that sine is not going to be equal to 1 until we rotate once more around the circle. So we have pi over 2 down here at 3 pi over 2, and we go another half circle to the top, we have 5 pi over 2. So we can also say 5 pi over 2 is equal to 2 pi t, and again canceling out pi and dividing by 2, we have t is equal to 5/4. And so there's a pattern. Again, if we go around once more and we add another 2 pi, we're going to have, that'll be 9. I'm just adding 2 pi every time. So 9 pi over 2 equals 2 pi t. And for this, t is going to be equal to 9/4. And if we went around another time, it would be 13/4 greater than t. So we will say particle at rest where t is equal to 1/4, t is equal to 5/4, and t is equal to 9/4. And why? For justification, because v of t is equal to 0 at each of those values. And those are all the values between t equals 0 and t equals 3. Okay, the next one, what is the maximum velocity of the particle between 0 and 3? Show the analysis that leads to your answer. Well, what we're going to have here is to find the maximum velocity, we're going to have to look at find the critical points for velocity. And how do we find that? Well, we're going to have to use acceleration. So we're going to say, we're going to take this acceleration, a of t equals 0 equals negative 4 pi squared cosine of 2 pi t. Okay, so basically what we're going to do is we can divide by 4 pi squared and rewrite this as, I'm just going to work to the right here to save room. We can set 0 equal to negative cosine of 2 pi t. And where does that occur? Well, where we have cosine equal to 0 is right here at pi over 2 at the top of the circle, and also at the bottom of the circle at 3 pi over 2. So we can say those become our critical numbers. You can see that that cosine is 0 along this y-axis. So really, let's go ahead and set that up. We'll say we can say pi over 2. Let me go farther to the left. Pi over 2 equals 2 pi t, and if we divide by pi, we have t equals 1/4. Now, for the next critical number, we can set this bottom value here, pi 3 pi over 2 equals 2 pi t, and dividing by pi and 2, we get t is equal to 3/4. And we can go ahead and say, go up again to 5 pi over 2 equals 2 pi t. For that we get t is equal to 5/4. So basically we're adding, the next one is going to be t equals 7/4, and then adding another half, we're going to get t equals 9/4. And then we have t is equal to 11/4. So those are going to be all of our critical numbers. And we can write the critical numbers like this on a number line. Okay, we have between 0 and 3, we have 1/4, 3/4, we have 5/4, we have 7/4, we have 9/4, and finally we have 11/4. And these are all the critical numbers we have. And I'm going to put on the top here A of t, and below I'm going to put V of t. So we can just put numbers in for this, and I'll put it right into this. I guess for sign purposes, I can put this negative cosine 2 pi t if it's negative or positive. So if we go ahead and put in 0, because 0 is a number to the left of 1/4, 2 pi times 0 is going to be just cosine of 0. And what's cosine of 0? Well, cosine of 0 is 1 right here. Okay, but negative cosine of 0 is -1. So we're going, so minus, so V of t is going down between 0 and 1/4. And now picking a number between 1/4 and 3/4, if we plug in, for example, 1/2, well, what's going to be 2 pi times 1/2? Well, that's going to be pi. Well, what is the cosine of pi going to be? The cosine of pi is -1. So -1 times this negative out front is positive. So here we're positive. And then between 3/4 and 5/4, we're going to have 2 pi. Well, 2 pi is going to be the same as 0. So we're negative here, going down. And then we can see that we have the same oscillating pattern between these critical numbers. Okay, then positive. Oops. Positive. And then negative. And so what says, what is the maximum velocity of the particle? Well, we can see that that we're going to have relative maximums up here at 3/4, 7/4, and 11/4. So we can choose any one of these because they're going to be exactly the same. So it says, what is the maximum velocity? So we're going to say V of 3/4. What is that equal to? Well, it's going to be equal to what we have up here, 2 pi minus sine of 2 pi times 3/4, which is going to be equal to 2 pi minus sine of, this simplifies to 3 pi over 2. And that's going to be equal to 2 pi minus the sine of 3 pi over 2 is going to be it's going to be, excuse me, it's going to be 2 pi times out front. So it's going to be 2 pi times that. So 2 pi, that's going to be 1. and negative 1. So it's going to be positive 2 pi. So our answer for this is going to be 4 pi. That's going to be our maximum velocity on this interval, 4 pi. So what I did is I went and graphed this function. If we go to y equals, here's the function, and here the function is graphed in an appropriate window, and we see the decreasing between 0 and 1/4. V of t is increasing between 1/4 and 3/4, and so on. And as far as what the acceleration looks like, it is going to be, I'm going to put this in red, negative, it was 4, let me see what it has here for acceleration, 4 pi squared cosine, 4 pi squared times cosine 2 pi x. And here we have it, graph. So it's really hard to, let me get a window. It's a lot bigger here. We'll go from y max to 30, y min maybe negative 30. Yeah, so we can see a little bit better. So we see negative up to 1/4, positive between 1/4 and 3/4, and so on. And then as far as that maximum velocity will be right here. If we go to second trace, maximum, and we can take any one of these, go to the left, press enter, go to the right, press enter twice. We get a maximum where x equals 3/4 of 12.566, which is 4 pi. So that's it. I hope this has been helpful to you. Good luck, and thanks for viewing.